Here we have the function f of x equal to x to the n, and we want to find the derivative for x to the n, where n can be positive or negative. And then obviously if n is 0, then we just get 1, and the derivative of a constant is just 0. If n is 1, then we get x to the first, which we have done earlier, and the derivative of x to the first, which is just 1. And so now we want to develop a formula for something like this, x to the n. And so first let's look at the binomial expansion. Notice that if we have a plus b to the first, then it's just a plus b. And if we have a plus b to the second, then we get a to the second plus 2ab plus b squared. If we have a plus b to the third, then it becomes a to the third plus 3a squared b plus 3ab squared and b to the third. A plus b to the fourth is a to the fourth, and then 4 times a to the third times b plus 6a to the second times b to the second. And so notice that the sum of the exponents have to add up to 4. So here you get 4, and then this is 3, and this is 1, where the sum is 4. And this is 2 plus 2, which is 4, and so on. And then for a plus b to the fifth, then we get a to the fifth, and then 5a to the fourth plus b. So 4 and 1 make 5. And then plus a to the third, b to the second. And then plus 10, a to the third times b to the second. And then plus 10, a to the second times b to the third. And 2 and 3 make 5. And then 5 times a to the first, b to the fourth. 1 and 4 make 5. And so instead of a and b, if we have x plus delta x, then x would be just like a, and delta x would be just like b. So we get x to the fifth plus 5x to the fourth times delta x, and then plus 10x to the third times delta x to the second, and then 10x to the second times delta x to the third, and then plus 5x times delta x to the fourth, and then plus delta x to the fifth. And so the first two terms is going to be a 5 here, a 5 here, and then 5 minus 1 here. And then the last two terms is going to be a 5 here, and then a 4 here, and then a 5 here. And so notice that pattern. And therefore, x plus delta x, and then before we get to this part, and then notice in here, this term has a delta x to the second, and then this term has a delta x to the third. And then if we want to expand x plus delta x to the sixth, then we can expand the first two terms and then the last two terms, and then we can make comments about the terms in between. And so this will be x to the sixth, and then times 6, and then 6 minus 1, and then times delta x to the first. That's the first two terms. And then the last two terms will be 6x times delta x to the fifth plus delta x to the sixth. And then the terms in here, the next term will have delta x to the second. And then the next term will have delta x to the third. And then the next term will have delta x to the fourth. So there are 3 more terms in here. Now let's get the pattern for the x plus delta x to the 7th. And so we get x to the 7th times 7, and then times x to the 7 minus 1, which is 6, and then times delta x. And the last two terms would be 7 times x to the first times delta x to the 6th, and then plus delta x to the 7th. The next term in the next term we'll have delta x to the second, and then the next term we'll have delta x to the third, the next term we'll have delta x to the fourth, and the next term we have delta x to the 6. So this is delta x to the first, and then next you get delta x to the second, the third, the fourth, the fifth. And then we get to the term that's next to the last. This is delta x to the 6, delta x to the 7. And so if there's 7 here, then we have a total of 8 terms. So we get 2 here, and then 2 here, and then 4 in the middle. And then let's do one more, and then we'll try to get x plus delta x to the n. For x plus delta x to the 8th, then the first term, then there will be 9 terms altogether. The first term will be x to the 8th, and then we get a times x to the a minus 1, which is 7. And so this number right here is always going to be 1 less than this number. And then times delta x to the first. And then in between, the next term we'll have delta x to the second. The next we'll have x to the delta x to the third, the fourth, the fifth, the sixth. And then we'll get to the last 2 terms, which is the 7, delta x to the 7, and delta x to the 8th. And now see if we can get the formula for x plus delta x to the n. It's n here, so we can get x to the n. And then we get n here, and then 1 less. So if it's 8 here, it's 7 here. If it's 7 here, it's 6 here. So if it's n here, then it'd be n minus 1. And then the terms in between the next one, we'll get x to delta x to the second, the third, the fourth, the fifth, all the way to delta x to the n minus 2. And then we get to delta x to the n minus 1. And then we get to delta x to the n. And we will need this formula to get the derivative for x to the n. This is the difference quotient. The function we're dealing with is f of x equal to x to the n, and we want to find the derivative. And so by definition is f of x plus delta x minus f of x divided by delta x. And so this will become this. F of x is just x to the n. And then f of x plus delta x, then in the place we just replace x with x plus delta x to the n. And so right here we have this. And so our difference quotient becomes this. And so let's find this part. So this is x plus delta x to the n minus x to the n dividing by delta x. We just developed the expression x. We've just expanded the expression x plus delta x to the n, which is this. And so in the place of x plus delta x to the n, we have this. So x plus delta x to the n minus x to the n, then it's going to be all of this, minus x to the n. And so here we have x to the n minus x to the n, which is 0. And so we just have this part dividing by delta x. So it's going to be n times x to the n minus 1 times delta x, and then all the terms in here, and then the last 2 terms, dividing by delta x. And that's what we have right here. this term dividing by delta x is just going to be n times x to the n minus 1. The next term dividing by delta x, and this is going to be down to delta x to the first, so it'll be delta x to the second dividing by delta x, then it's going to be something times delta x to the first. The next term, which has something times delta x to the third, dividing by delta x, then we get something times delta x to the second. The next term, which is something times delta x to the fourth, dividing by delta x, and we get delta x, something times delta x to the third. And on down to the last term in here. Then we get delta x, something times the last term in here is going to be something times delta x to the n minus 2, dividing by delta x. This is like delta x to the first. And when we divide, we subtract the exponents. So it's n minus 2 minus 1, because this is like delta x to the first. And we end up with the last term in here is going to be something times delta x to the n minus 3. And this term, next to the last term, dividing by delta x, is going to be nx. And then again, when we divide, we subtract the exponents. This is just like delta x to the first. N minus 1 minus 1, then we get n minus 2. And then the last term is delta x to the n, dividing by delta x, be just n minus 1, delta x to the n minus 1. And now to get the derivative, we'll take the limit of this, which is the limit of this right here. The limit of the first term as delta x approaches 0 is just this, because there's no delta x in here. There's no delta x in this term. And so we get n times x to the n minus 1. The next term has a delta x to the first. But as delta x approaches 0, then this term be 0. The next term has a delta x to the second. It also goes to 0. And so, in fact, all of the terms in here will go to 0, because each one has a delta x in there. This term has the delta x, so it goes to 0. And then this term has the delta x, so it goes to 0. And so the answer is going to be n times x to the n minus 1. And so for summary, for f of x equal to x to the n f prime of x which is equal to this, and it's going to equal to this. And we've only shown the case where n is positive. And so the question becomes, what happens if n is negative? And then for n negative, then we need to use what's called the quotient rule. And once again, the quotient rule is that if we have derivative of f of x divided by g of x, then this is the quotient rule right here. And so now let's see, we will see that the formula is the same if we, for n negative. And so if n is negative, then negative n is positive. So now what we're going to do is let m be negative n, which is greater than 0. And which also means that n is equal to negative m. And now we want the derivative of x to the n This is the same as the derivative of y with respect to x of x to the negative m, because that's what n is. N is negative m. And then this becomes the derivative, and then for x to the negative m, we can write it as 1 over x to the m. So we have a negative right here, and then we can write it as 1 over x to the m. And then now we can use the quotient rule right here. So think of f of x as 1, and then think of g of x as x to the m. So it's going to be g of x, which is the denominator here. So be x to the m times the derivative of f of x, which is 1, and then minus f of x, which is 1, and then times the derivative of g of x, which is x to the m. And notice that m is positive, because m is negative n, so m is positive. And then dividing by x to the m squared. And this is the derivative of the constant 1, and derivative of a constant is 0. And so 0 times x to the m, that's going to be 0. And this is 1 times the derivative of x to the m. M is positive, because m is negative n. But for positive exponent, we just got this formula right here. And so the derivative of x to the m, where m is positive, is going to be m times x to the m minus 1. And then this is x to the m to the second. Then we just multiply these two exponents together. So that becomes x to the 2m. And this will be negative. And then this is x to the m minus 1 divided by x to the 2m. And again, when we divide, we subtract the exponents here. So this will be negative m times x to the m minus 1 minus 2m. And then this is negative m times, and this is 1m minus 2m, so it would be negative m, negative 1m minus 1. Once again, this is m minus 2m, so it's minus 1m, but negative m is n. So we get n times x to the n minus 1. And therefore the derivative of x to the n is equal to n times x to the n minus 1 for n less than 0. So it's the same formula when n was greater than 0. Then we got this, the formula is the derivative is n times x to the n minus 1. And then when n is negative, we also have the formula n times x to the n minus 1. And therefore the derivative is equal to n times x to the n minus 1 for n greater than 0 or n less than 0. And again, if n is 0, then x to the 0 is just 1, and the derivative 1 is just 0. And again, this is called the power rule for derivative.